This is a short video to show you how to use the Arduino Portenta LORA board, which comes with a camera, and AI. So I'm going to take some pictures of some bulldog clips and just see if we can recognise them and also recognise what's not a bulldog clip. To do this, what we're going to do is use this software here called OpenMV, and this is going to help us capture the images, and then it will upload it to a service called Edge Impulse, and then within Edge Impulse that's going to give us a AI model at the end of it. Once it gives us an AI model, we'll open up and copy that across to the Arduino Portenta. So first of all, we need to actually connect to the Portenta. That's just connected up now. Once we're connected up, we press the play button and it's going to run this script here. So what this script does is it imports the sensor, image libraries and the time library. It's going to loop through and just save the information or take pictures intermittently. And then on the left hand side we've got these buttons here which will capture the image and we can create the folders that the images go into. So if we create a folder, we'll call this bulldog clip. So to actually get this dataset up, first of all, you go to dataset, new dataset. Because I've already created a dataset bulldog clips, that's fine, but you just create a new folder in there, select it, which we've already done, and this is the bulldog class that we've just created. So the next one's going to be non-bulldog. Okay, so that's created. So to create the images, just click on the folder in question, and then we need to play this script. So it's going to take pictures, and that you can see that's running through. And I've got all the bulldog clips here, so let's just get this orange one nearby. I've just got a LORA board connected to it at the moment, so I'm just going to disconnect that. What I can do is I can point it at the bulldog clip and just take lots of pictures. All the different angles. Alright, so I'm going to pause the video here. Okay, so I've took a picture of all the clips. I've got something like 327 pictures now. So that's good. So the next thing I need to do is I need to take pictures of the non-bulldog clips. I'm just going to get those spread across the table. So I've just got a piece of rubber, a USB, and that should do me for the demo purposes. So then I'm just going to, the script's still running, I'm just going to take a picture of each of these. So click, click, click. So click on all those, and then let's get some of this. Right, so I'm just going to stop the video while I collect the rest of the data. Okay, so I've took a picture of all the non-bulldog clips. I've got 226, so not quite as many, but I've got quite a few in there. So the next thing to do is to upload these to the Edge Impulse. Before we do that, what we need to do is we need to open up Edge Impulse, and we need to create a new project. So this is going to be, let's call this bulldog clips, bulldogs clips 2. I've already created one previously when I was just running through this, so I'm going to create new project. Okay, so that's created. We're just going to close that down and we're going to minimize this for the moment. Then we're going to go into Tools, Dataset Editor, and we can go into Upload to Edge Impulse. And then we're going to select Bulldog Clips 2, so the new project, and we're going to click OK. So it's asking us how much of the data is going to be used for training, so how many of those pictures are going to be used to train the model, and how many pictures are going to be used to actually test the model we've trained it with. So I'm just going to leave it on default, and OK that, and that's just going to upload. the next thing to do from here is go into Edge Impulse through the web browser and just select the properties of the model that we want to create. So it's got rid of a few marked as duplicates, that's fine. So I'm just going to click on OK to that and open up the web page. Okay, so I'm in the Edge Impulse. If we go over to data acquisition, we can see all the images that we've created. So you click on them and it shows you on the right hand side the images. So this is good. So what we need to do now is we need to go to the Edge Impulse design. We're going to leave these on as basic, and we're going to add a process. So at the moment we're going to choose the top one, which is image, but you can do audio, you can do spectral analysis, spectrograms. There's all sorts of different things you can do with Edge Impulse. So this is a processing block, so this isn't using AI, but it's pre-processing it before we put it into the AI model. So we've added that one. If we go to add learning block, and then we go to add images, and then we go to save impulse. We now click on image. We want this as grayscale because the camera we've got on the Portenta is just grayscale, and there's no point doing it in colour. I'll keep the, I think it might tell you actually. No, it doesn't. I thought it might change the processing time at the bottom. We'll keep it all as grayscale. We'll save the parameters, and then we'll generate the features. And what we'll get on the right hand side is a explorer where it clusters all the images together, and hopefully it should separate them out. So just leave this to run through. Okay, so that's finished, and we've got this little explorer. So ideally what you want is all those to be as far away from each other as possible. So you want the blue and the orange to be separated. But they're quite clumped together in this, so this model's probably not going to be so accurate if we was just running this on its own. So what we need to do now is put this into a deep learning model, and that's what we're going to do next. So it's actually called transfer learning. So it's using a model that's already been created, already been trained on some images, and we're just going to be tweaking it slightly for the bulldog clips that we took pictures of. I'm going to leave everything as standard, apart from I'm going to take data augmentation. If you hover over it, it tells you what it is. And what it does sometimes with this kind of stuff, it moves the images slightly, maybe angles them, changes the colour sometimes on them, changes the shadow. It can do quite a lot of different things, but it just helps you train the model without it being too specific for your images, the objects in the images that you're training it on. So if we start the training, this will run through. Usually takes about 3 or 4 minutes for this. Depends on how much data you've got. So you can see on this as the model's getting quite good accuracy here. We've got 97%. So we keep flicking up from 97 to 99. So 99% is very good. And we've got a validation loss, which is quite low, and validation accuracy, which is good as well. So that's on the validation set, it's testing the model. So this looking quite good at the moment. It's then going to try and build this into the actual model after, so into TensorFlow. We'll just leave this to run through. Okay, so the model's completed. That's good. We've got a 97% prediction on the bulldog clips and a 95% on that one, so that's good. So only a 5% chance of getting it wrong on the bulldog clips. So that's good. So if we change that to a float, it doesn't improve it much, but we're going to use it on this one as well because this runs on a we could probably run on an unoptimized flow tinter. There's not that much difference, so we're going to leave it on the quantized 8-bit. So that's the training done. So the next thing to do is to go to the model testing. So this is going to validate the results on, so these are images that have not been used in the training or validation, and it's just going to run the algorithm over these and give us a classification for them. So I'm going to click on classify all here. So it'll just take a little time to run through. Okay, so we've got 1, 2, 3, 4, 5, 6, 7 that are being classified incorrectly. It's not bad for a first run. We'll probably need a few more images, and we'll probably inspect why those images. It may be that I've took a picture of something incorrectly, because I did it quite quick when I was running through it. So I'm happy with that. Next thing to do is to deploy. So click on deploy, and then we've got all the different devices that we can deploy it to easily. We can apply this to more, but this gives us a bit of a head start. So you can export it as a C++ library, Arduino, so you can import into the Arduino IDE and edit it that way. Not sure what that cube is. If you want to send it to Jetson Nano, WebAssembly is a new type of way to develop. It's got quite good reviews for the websites, but we're going to send it to OpenMV. You also can send it to Linux as well, which would be your Raspberry Pi boards. So click build on here, and that's just created these files here. So I'm just going to drag this up, and they're the 3 files that you need to run this model, and they just got copied over to the Portenta. So that one is the actual file that tells you Python file that runs the model. This is the labels, so the 2 classes that are created, bulldogs and non-bulldogs, and then this is the actual model itself. I'm going to minimize that for the moment and just show you this here. So this will tell you how to run the model, so you can actually view this and copy it across, but I'm going to show you this anyway. I just thought it would be useful to show you the documentation that Edge Impulse have created. Okay, so that's done. So what I'm going to do is going to bring up that window again. Here we go. I'm just going to copy those, and I should have a E drive down here, and I'm just going to overwrite what was in there and replace. Okay, so let's minimize that. Let's go back to OpenMV, go to File, Open, and then we're going to choose the E drive, and we're going to choose this one here. It's just loading now. There we go. So it's going to import the relevant libraries, so the sensor library, the image, and the TensorFlow Lite library. It's going to get the sensor ready, so the camera. It's telling you what the file name is of the model that we just exported, and it's going to get the labels from the label file, so the 2 classes. And then it's going to, this bit here is just running the model, so it's collecting an image from the sensor, and then it's running that through the model. So this bit is the running the model, just here. So what I'm going to do is I'm going to start this. So first of all, I'm going to connect to the device, and then I click play. Alright, so you can see at the bottom here is it's telling you what the prediction is. So if I put the image over on the right hand side, you can see it's top right, it's over a USB stick, and it's detecting that as a non-bulldog. So if I get a bulldog clip, hover it over there, and it's telling you that it's got high confidence that that's a bulldog clip. So that's the model working. So I'm happy with that. So I'm just going to stop it there. And what I'm going to do is I'm going to hook this up, or make this script a bit bigger, and work on some of the LORA stuff that we've used previously. So the LORA is going to make a prediction, and then based on that prediction it's going to send it online. So I'm just going to pause the video and then just open up the LORA script. I've copied all the files over to the E drive, and I've opened up the same file, but obviously the updated script in there. So the same file name, but different script. And this is going to connect to the Things network. It's going to take a picture. That's going to run that picture through the TensorFlow Lite, and then it's going to make a prediction. And then from that prediction, it's going to send that prediction over the LORA network. So I'm going to put this up to our GitHub, so it's in the comments below. And let's just run this to see what happens. So you can see down the bottom here, it's just making a connection. So it's connected, it's made a prediction. So the predicted value is a non-clip with value of 9.5, so it's 94% confident. So if we get a picture of a clip here, it's going to wait for 2 minutes. So I'm just going to pause the video here. Okay, so the prediction run, and it's predicted that it's a clip, and it's predicted as a clip with a 96%. 93%, sorry. So let's check the Things network, and we'll see whether that message has come through. Just a wrong web page. So if we scroll up, we can see the latest message, clip 93%. And that's the script. Thank you.